We will be recording and publishing the Climate Cafe. So as I said earlier, if you don't want to be recorded, then switch off your camera and switch off your microphone. I muted you during the presentations. There are 3. It's a usual routine of 20 questions per speaker and then a Q&A session afterwards. You can use the chat facility to type in any clarifications or points, but please do keep your questions till the end. To ask a question, as we've already said, you just pop an asterisk in the chat, state who you're directing question to, give a quick summary of your question, and wait until your name is called. And then just at that point, you'll be allowed to unmute yourself. And when you finish asking the question, if you just mute yourself again, that's easier for everybody and prevents any kind of horrible feedback. If you would prefer Jeff to ask a question for you, then just say that in the chat. So this Climate Cafe is our very first one online. It's very exciting. Hopefully it all goes well. I'm sure it will. It's about new innovations in energy and heating. And we've got Mrs. Beena Sharma speaking first on cutting heat loss in granite walls, the science and the solution. And after Beena has spoken, then Tara Luma will speak on clean tech options within buildings. And last but not least, David McGrath will be speaking about understanding the whole house energy in layman's terms. How do you approach energy sufficiency? Now, we're trialing something new because why not? It's a new normal after all. So if you have any further kind of questions or you want to join discussion with David McGrath about the contents of today's cafe, so on kind of clean tech and energy reduction, energy efficiency, renewables in your home, then on this Thursday, the 7th at 7 p.m, you can join him in a chat session on Zoom. The link is on our Facebook page on this event, basically on the Thursday the 7th event, the follow-up discussion. So just go for the link there. I don't know when the lockdown is actually going to finish. None of us do. So we're going along thinking that's going to be online for the next couple of months. And if we can get them back at the Belmont before that, then great. But otherwise, we will be doing all our future cafes until a point that we can all get back together online using Zoom. So the next one, on Tuesday the 2nd of June, will be about the future of public transport. After that, we have innovations in agriculture and then fish farming. So that would be great. Obviously, our media is here, our website, the Climate Week Northeast website, our Sustainable Living portal, which is actually really quite important. It has a lot of information about how to live sustainably, and also gives you details about local sustainable food growers, which we should be supporting this time. Our Facebook page, our Twitter, Instagram, and LinkedIn. So without further ado, I'm going to pass you over now to Beena, who's going to kick off our Climate Cafe tonight. Thank you.
Thank you, Alison. Thank you to all of those at the Climate Cafe as well for inviting me to speak. I'm just going to try and see if I can share my screen with you. Hopefully you can see that. My name is Beena Sharma and I am the Managing Director for Orbis IWI Innovations. I introduced myself briefly to the Climate Cafe a couple of months ago. Might have been the last session that we did before lockdown. So some of you I have met. There was a fair amount of interest in what we're doing here at Orbis to make a difference. So hopefully today can give you a little more information. We're an innovative company that focus on breakthrough solutions in insulating homes. Today's topic will be about the science of heat loss in granite and sandstone walls, and would like to bring to you a solution based on this science. But in order for us to do that, we need to look at the context in which this is set. So we can do a number of things in order to reduce carbon emissions, but to make a real difference, we need to do at least one of two things. We can replace our energy sources with non-carbon sources, and those might include things like solar, hydro, wind, etc. which have been slowly growing over the years. We can also reduce the demand or reliance on these traditional energy sources. Our focus energy is on home energy at Orbis. Why? Because on average, home heating is attributed to around 65 to 70% of home energy demand. We know that energy costs have risen over the years, making it less and less affordable to heat our homes. And we also know that these costs will more than likely continue to rise in the future. Climate change and elimination of fuel poverty are two strategic objectives for the Scottish Government. They are committed to spending billions of pounds in years to come to improve our homes, making our homes more energy efficient, and also making our homes cheaper to heat and maintain. Here in Scotland, we are quite unique. We enjoy a terrific legacy of granite and sandstone buildings. They are lovely, lovely to look at. But if you've ever lived in one, you will know that they are terribly expensive to heat and upgrade, not to mention very cold, especially through the winter. Let me introduce you to us as a company. We were set up recently to commercialise a new internal wall insulation system, which was designed specifically for granite and sandstone buildings. Why granite and sandstone? Well, we recognise that traditional methods of insulating such buildings do not seem to produce the same performance as they would do for other types of buildings. So the average heat loss through walls is around 30%. Heat loss through granite is much higher, around 50 to 60%, could even be argued that it's higher. We have an abundance of these properties that are being left empty, unloved, and will eventually probably be knocked down to make way for newer buildings. If maintaining and upgrading these buildings were cheaper, easier, more efficient, then this doesn't need to be the case. At the very heart of our design is understanding why these buildings are so hard to heat and what makes them so unique. So we enlisted the support of RGU's, Robert Gordon University, Scott Sutherland School of Architecture, and they analysed and characterised our design. We have devised what we believe to be the most efficient insulation method for these iconic buildings. Their analysis shows up to 93% reduction in heat loss in the treated walls with our internal wall insulation. So let's look at what the issue is with granite and why is it so hard to heat. So we start with one simple rule. The heat that you require in a property is equal to the heat that leaves it. The image on this slide shows the different heat loss paths. Heat escapes or transfers by three mechanisms. They are conduction, convection, and infiltration. Conduction is when the heat is transferred from the warm to the cooler part of the solid wall. Convection is when the heat is transferred and replaced by cooler air. So the air flows up from under the floor, up inside the lath layer, and ends up in the loft. And the infiltration losses happen via the leakages in the building construction, such as the cracks, the gaps, the window around the windows, electrical points, etc. The outer wall itself is ineffective as a heat barrier. The only effective insulation is therefore the lath and plaster. Hence the difficulty in retaining heat in these types of buildings. Now, retaining the airflow behind the lath and plaster is vital. This is what keeps the granite surface and the inner lath layer dry. U values. So for those of you that aren't aware, U values are a measure of the flow or the rate of heat transfer through an insulating or a building material. The lower the value, the better the insulating material. The higher the value, the greater the heat loss. BRE, which is the Building Research Establishment, expressly states in its handbook that when calculating the U value, if the cavity is ventilated, then the outer granite layer is excluded from the calculations. Now, either this is ignored or maybe it's just not made aware that the cavity is ventilated, and because of this you would end up with a lower U value, 1.3 as opposed to 4.3. The difference itself is huge. If the cavity layer is of course filled with insulation, then at that point the granite layer is considered in that calculation. What are the current insulation solutions available on the market at the moment? We have external insulation, is quite common. The cavity remains, as we said, as per BRE guidelines, and the external insulation is rendered useless. Stripping out and relining, this can possibly involve timber frame. It appears to be the best solution, but we also know that this is both costly and very, very messy. And you'd have to be pretty brave to do this without moving out. Filling the cavity, for obvious reasons, would not be recommended and can create further problems. Daub and dab, now this is, for example, the gluing of insulation boards directly onto the lath layer. The lath, of course, would need to be sound, which unfortunately in these types of buildings often it isn't. Framing with timber and insulating, this can be costly and doesn't address cold bridging issues. And also one some of you may have heard of before, Matilda's blanket. The Orbis system is similar to Matilda's blanket, but the Matilda's blanket system is 3 times the cost of the Orbis system. So the Orbis internal wall insulation system, our system is an engineered form of framing and insulation, which has been tested and characterized by RGU Scott Sutherland School of Architecture. It's designed to be fast to install, with minimal mess, more affordable than competitors, more effective, and also impart structural integrity to walls. What benefits does the Orbis internal wall insulation system bring? Up to 93% reduction in heat loss through treated wall. That's quite high. We also support local business, trades, economy, jobs, etc. Of course, it adds to the home and the rental value. Improved air quality, so improved health, well-being. As we mentioned before, minimal mess and disruption. There would be no need to move out of the home. More than likely, you could just move the furniture to one side. It's quick and easy to install. The house is cheaper to heat and stays warmer for longer. It comes with a product and install guarantee, and we only use trusted and certified installers. Let's look at the results that we found. Remember, the U value, which is here in red, is how we express the rate of transfer of heat through that wall. So here we've got 2 U values, one for uninsulated and the other one for the insulated Orbis internal wall insulation system. So the temperature in the cavity is 0 degrees, and the temperature we want the room to be is 21 degrees. The heat loss is 90 watts per square meter. Now this is a 20 square meter wall. The house is heated for 180 days and per year, and on average of 12 hours a day. If we compare the results we get for the uninsulated with the insulated, the total heat loss difference and carbon emissions difference is pretty big, assuming that the energy costs stay the same. What does this mean in terms of cost per year? Well, £18.15 as opposed to £233.51. That's a 92% saving. The cost of insulation here would be less than £2,000, and the payback is somewhere between 7 to 9 years. So the next slide I'm going to show you is an animation of how the internal wall insulation is actually installed. I'll try and talk you through it. Some of it is a little bit quicker than I can talk through, but here goes. So this is your typical wall. first, oh, let me try that again. Right, here we go. So to start with, the timber battens go on top of the lath and plaster. These pick up the vertical battens that hold the lath. And the blue section you see here is our carrier system. These are what holds the insulation boards in place. So you'll see the insulation boards going on there. The survey and thermal imaging is carried out prior to the install. From this, we can easily identify cold bridges. Of course, debris, for example, may build up over the years, and once identified, we can wrangle this out before we do the install. Any services such as light switches, electrical points, radiators, etc., they can all be brought forward where required. So that's the installation going on. And then on top, we have the plasterboard, and that is followed by AIMS tape and decoration. So it could be argued that probably the most timely job would be the AIMS taping. It's quick and easy to install. There's no need to move out. Our carrier is cheaper and easier to work with on site than any of our competitors, and it has better thermal performance, especially at cold bridging sites. The Orbis internal wall insulation approach is architecturally led, and the system is deliberately designed to be cost effective, easy to install, minimal mess. The benefits the system can bring are huge, both in terms of carbon emissions and eliminating fuel poverty. Our launch has unfortunately been delayed due to the current climate. We were due to launch, well, we should have launched by now. But obviously we've had to change that, and our aim is to launch within a short time frame of lockdown conditions easing. We're also looking for investors. This may appeal to private investors, in particular those that are looking for ethical investment opportunities. I know that's always a difficult one. Our ethos is based on reducing carbon emissions, supporting the local economy, and preserving the life of these iconic buildings by making them affordable and easy to upgrade and maintain. Contact us for further information if you'd like to get involved, you'd like to invest, or interested in the system for your own property. Please do get in touch. I'll end on by saying thank you, Alison. I look forward to some of the questions at the end. And that's about it. I think we can pass on to the next speaker, Alison.